So this is going to work with polynomial and rational inequalities. So question one, we have solve the inequality. Notice this is a polynomial inequality. So we have this polynomial x squared plus 2x minus 15 is greater than 0. So remember, greater than 0 kind of means this side's got to be positive. So to be greater than 0, we have to have a positive value. So we're trying to figure out the values of x that generate positive values. Now, the strategy to do this is to find the zeros. So one way to find the zeros is we can set x squared plus 2x minus 15 equal to 0. To find the zeros, it's got to be, is it factorable? Yeah. Bless me, sorry about that. So we look at, since the coefficient of the quadratic term is a 1, all we have to do is look at the factors of a negative 15, but they have to add to give me this, this negative 2. So the factors of 15 are a 1 and a 15. 2 is not a factor of 15. 3 is a factor of 15. 3 times 5 is 15. 4 is not. And then 5 times 3 is, so that's repeating the same factors. So we really just have two pairs of factors. The one that has the best promise of giving me this negative 2 would be this 3 and 15. So to get a negative 15, one of them's got to be negative, but to add and get a negative, the bigger number has got to be negative. So we have to have a 3 and a negative 5. So 3 times negative 5 is negative 15, and 3 plus negative 5 is negative 2. So we can break this into two factors. X plus 3 is one of the factors, and x minus 5 is the other factor. So to find the zeros, all we have to do is set each factor equal to 0. That's that multiplication property of 0. So if you set x plus 3 equal to 0, we would see that x equals negative 3. In other words, its opposite would have to be that. So if I put a negative 3 in, this factor turns into a 0. And again, it doesn't really matter what this is, because when you multiply by 0, the answer is going to be 0. So that's called a 0. So then we have x minus 5 is equal to 0, and then that would have to be a 5. So our two zeros are a negative 3 and a 5. So we could put those up here. We'll use little tick marks to start with negative 3 and a 5. Notice that we have to be greater than 0. So these actually are not included in our solution. So these are going to be open intervals as well. So we're not going to be including these zeros in the answer. Now, another way to find the zeros, I could be using the quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So x would equal the opposite of b. Well, b is this 2, so the opposite of 2 is a negative 2, plus or minus, and then we'd have the square root of, and then b squared would be 2 squared, minus 4 times a. A is the coefficient of x squared, which is a 1. And the c is the negative 15. And this would be all over 2 times a, and 2 times 1 would just be 2. So if I was doing the math, I would have to do 2 squared minus 4 times 1 would have been 4, times negative 15 would actually be a negative 60, and 4 plus 60 would be 64, actually. So yeah, we would have x equals negative 2 plus or minus the square root of 64 over 2. Now, the square root of 64, since 64 is a perfect square, we know that 8 squared is 64. The square root of 64 should be 8. So if I do the square root of 64, that should simplify down to 8. So what we have then is negative 2 plus or minus 8 over 2. So if we separate this apart, then we have negative 2 over 2 plus or minus 8 over 2. So this would actually be a negative 1 plus or minus 4. So negative 1, let's see here. So negative 1 plus 4 should give me a 3. So interesting. Let's see if I did something wrong up here. Yeah, I did something wrong. The this was actually a positive 2, not a negative 2. So I've got these signs backwards down here. Backtrack a little bit. You probably saw that. You're like, what's he doing? So we need the factors of negative 15 that give me a positive 2. So that means the negative 3 should be negative and the 5 should be positive. So negative 3 times 5 is negative 15. Negative 3 plus 5 is actually a positive 2. So we should have x minus 3 times x plus 5 up here. So that means x minus 3 should equal 0. So x equals 3. X plus 5 should equal 0. That's going to equal x equals negative 5. So that does give me negative 5 and 3 are my zeros. So that kind of helped me to double check myself. So negative 1 plus 4 would be 3. Negative 1 minus 4 would be negative 5. So that would give me the same zeros. Now, again, you could use graph behavior on this as well to find the zeros. So what I mean by graph behavior, I'm sorry, to complete the problem. So we already found the zeros. So to complete the problem, if I want to use graph behavior, notice that this is a quadratic and it does open up. So what I can do is sketch the graph here. Just roughly kind of treat this like the x-axis, if you will. I'm not actually drawing the y-axis in, but the y-axis would be in there somewhere, but we don't really need it. So again, if you're above the x-axis, we're positive. If you're below the x-axis, you're negative. If you're above the x-axis, you're positive. So since we were looking for positive values, notice that that's going to happen left of negative 5. So like negative infinity to negative 5, or from 3 to infinity would be what we're kind of picking up on. So that would be the solution to this problem, is that's where it's positive at. Now you also could graph the function and watch the behavior in the table. So if I hit like y equals, if I clear this off and type in x squared plus 2x minus 15, if I graph that, you can kind of see we're getting the same kind of thing here. The zeros are negative 5 and 3. And remember, you can also use the calculate button to find zeros that way. So if I hit second table, though, you can also kind of see that if you look here, if you go, there's that negative 5. Notice that if you go left to negative 5, notice that all your y values are positive. So that means if negative 5, negative 6, when negative 6 goes in, it makes a positive value. And again, a positive value is greater than 0, so it's going to make a true statement. So any number left of 5 should work. And we're not just talking integers. We're talking fractions and decimals as well. So we're just not going to play with those fractions and decimals. It's just understood that they're part of the solution. Notice that once you go past negative 5, notice that negative 4, negative 3, negative 1, 0, 1, 2, they're all negative values. Notice that you're below the x-axis here. If you look at the graph over here, you're below the x-axis. But if I come back over to the table again, if I continue on, notice that once you get past 3, 4, 5, 6, 7, 8, 9, notice how again you're getting positive values here. So you should be able to see the solution as well using the table. So notice how the zeros are present. There's the 3 as a 0. There's the negative 5 as a 0. So you can also find those zeros just looking at the table since they're whole numbers, integers. So that's kind of what we're doing here, is we're kind of using zeros to start with, because that's going to break up the intervals. But also the zeros are not included because you have to be greater than 0. So they just kind of break it up. So left to negative 5 is going to be positive. Between negative 5 and 3 is going to be negative. And then to the right of 3 is going to be positive. So how did I know, again, this graph? Well, since it was quadratic, we know it's a parabola. And since the coefficient of x squared is positive, we knew that it opened up. So I can kind of do a rough sketch of it. And that's all I really need to help me solve this problem.